Okay, hello everyone. I'm going to take a look at just one question today. It's a part A and a part B. This comes from your May-June 2022 paper, and I'm just going to quickly take a look. It's May-June 2022 and it's paper 1-3. Okay, so let's just dive right into it. It's quite a tricky paper. Quite a tricky question, should I rather say. Okay, we've got a point lies on the line with this equation. So this is just a straight line. Okay, where M and C are positive. So if I want to just get my bearings throughout this question, I know that my gradient is positive, so it's not going in the other direction. My gradient's positive, and it's going to pass my y-axis somewhere above, somewhere in a positive, where C is going to be a positive value. Okay, so I'm just going to put it over there for now. A curve has that equation. Okay, so we can see this is a reciprocal function. So a normal reciprocal function looks like this. Okay, so all that we can see is that this thing has a gradient of m. So a gradient is going to change the shape of the function. It doesn't really change too much else. It just changes how curvy it is. Okay, but then the minus in front there, we can see a minus in front of the function means that it flips it. So here I'm taking all my y values and I'm making them negative. So if all my y values become negative, that means I'm flipping it over the x-axis. Okay, so this was my original graph. Now I'm going to flip it over the x-axis and it looks something like that. Okay, so I've got a straight line and I've got a reciprocal curve. So I'm just going to draw them both on the same coordinate plane. Okay, so this is how I orientate myself. You don't always have to draw, but it is kind of nice just getting an idea of what you're doing. Okay, especially if these are functions that you can recognize. When they start becoming the ones that are difficult to recognize, I wouldn't say you necessarily have to do it. Okay. Anyway, a curve has that equation. There's a single point P on the curve that the straight line is tangent to the curve. Okay, so this is going to be point P. How do I know it's going to hit that one? Because if it was here, my value, my y-intercept would be negative. Okay, that's why we know it's not tangent over there. Just to say that again, so here, can you see they both have the same gradient, right? So both of these have the same gradient, but what's different is that the one's going to have a positive C value and the other one's going to have a negative C value. We want to use the one with a positive C value over here. Okay, there is a single point P on the curve such that the straight line is tangent to P. Find the coordinates of P, giving the y coordinate in terms of M. All right, so we need to find the coordinates, so we need to give them an x and a y coordinate, but it's going to be in terms of M. Okay, so first thing I want us to remember is whenever we have a tangent question, when you see a tangent question, there are 3 different types of tangent questions in Pure Math 1. Okay, 3 typical tangent questions. The one is we derive it, and then you plug in a point. Plug in your point to get the gradient at that point, and then you can get the straight line, and that's going to be your tangent. Okay. The other way of solving this is a discriminant question where your discriminant is equal to 0. That means the line and curve only have one point where they intersect. Okay. And the third one is normally if you have a circle and tangent to the circle. Here you're going to be looking at your gradients on the inside and then the gradients on the outside. You can use your perpendicular formula. Okay, so we know that we're not going to be using this one, okay, because we don't have a circle here. We've got a curve and a straight line. So I'm going to try and do this both ways, just to show you how you could do either way. Okay, what you need to remember is the steps in the background. Okay, so if I just talk through this one, we have to differentiate our curve. Then, in this case, they've given us the gradient at the curve. We know the gradient of this line is M. Okay, so that means the gradient at this point, whatever this point is, my dy over dx is going to also equal m. Okay, otherwise there wouldn't be tangent, right? So I'm going to plug in, well, I already have my m value, so I'm going to then solve for x. Once I've got my x, I can then find my y by plugging it back into the original formula. Okay, so that's one way to do it. If I just quickly think about my discriminant, what happens with my discriminant is I normally get a curve and I make it equal to my line. Then I bring all my terms to one side and I end up with a new quadratic. Okay, maybe I can just write here new quadratic. And what am I going to do with my new quadratic? I'm going to force it to only have one answer. So I make my discriminant equal to 0. Okay, once I've forced it to equal to 0, I should be able to figure out what my m or my c value is, or my c value in terms of m or my m value in terms of c. When you use a discriminant, you're not solving for x. Okay, you're not solving for x directly, so then I would still need to go back to my equation, my simultaneous equation, and actually solve for x. Okay, so I think I'm going to actually just do not question, but let's try doing it with differentiation, because that's going to get me directly to an x value. Okay, so I've got my curve. All right, now first of all, I differentiate my curve. Okay, I'm just going to bring this up, so that will help me to be able to differentiate with the power rule. Now I'm multiplying for differentiation. Those need to be multiplied, and then I'm subtracting another one. So that's mx to the power minus 2. Okay, so my gradient function is m over x squared. Okay, and now I know that the gradient at that point is m. Okay, so there's a lot of constants. Not constants, there's a lot of, yeah, there are actually constants in this equation that we don't really know the actual value of them. Okay, so here I'm going to solve for x. If I take my x squared up to the one side and my m down to the other side, I'm going to have m divided by m. If I square root of both sides, I'm going to have plus or minus 1. Right, now if we go back to our drawing that we had, we can see these are going to intersect over here at x is equal to minus 1. And the curve is also, it's got this also a gradient here where x is equal to 1. Right, but as we spoke about earlier, we know that it's only going to be valid if x is equal to minus 1. Okay, because if it was on the other side, it's not going to be valid because my c is then going to be a negative value. Okay, so what have I done so far? I've found the x coordinate of P. Now I need to find the y coordinate. Okay, so how do I find the y coordinate? I can go back to either my curve or my straight line and solve for y. So minus m over x. So I know my x is minus 1. So my y is equal to m. Or you could have gone into your straight line, but this is now a bit trickier. X plus c. So I'm trying to solve for y. I know my gradient is m. I know my x is minus 1. But now I haven't solved yet for c. Okay, so this is going to be a bit trickier here, and this is where I would then need to, what would I need to do? I'm thinking if you go the route of the discriminant, you're definitely going to figure out what c is. So for now, just in terms of my previous method, I've already found y in terms of m, so I'm just going to take these. This is my answer, and that is my answer. So my point B is going to be minus 1 and m. Okay, I'm not going to go directly into this right now, but I do want to, well, I want to encourage you to think about it. Okay, we would need to then maybe solve for C as well. Okay, All right, let us keep going. I'm going to take that. This is my point. Let's keep going with our differentiation method. So the normal to the curve at P intersects the curve again at Q. Okay, so now we're going to draw in our normal to P. I think I'm going to draw it in orange. The normal to the curve, so that must be perpendicular. The normal to the curve at P intersects again at Q. So you can see where our Q is already going to be. All right. So find the coordinates of Q in terms of M. Okay. So what we know the gradient of this tangent line is M. The gradient of this tangent is M. Okay. So the gradient of the normal is going to be what? Okay, the way that we find it out, we take our tangent. So our tangent times our normal is equal to -1. So the gradient of the tangent is M. So the gradient of the normal is -1 over M. Okay, now my equation of the normal is going to be y minus, I'm going to now plug in my point P, y minus M is equal to -1 over M, and then x minus minus is +1. Okay, so this is now my equation of the normal. I am going to make y the subject of the formula. Okay, so I just multiplied out my brackets and then I took my m to the other side. So this is my equation of my normal at P. So that's this orange line down here. Okay, and it intersects the curve again. So now I'm going to make it equal to my curve because I want to find out where is that point. So my curve is -m over x. So my curve is equal to my normal. Okay, so I think really what makes this question difficult is the constants. If this was just numbers, it would be so much easier. Okay, but we don't know what the value of m is, so we need to find it out. So now I'm going to try and clear my denominator. So common denominator here. So in my denominator, I have an x and I also have m's. So my common denominator is going to be xm. Okay, so here we need another m. Here we need an x. Here we need an x. And here we need an m and an x. Okay, now this is where it gets really a little bit tricky. I do find this question quite mean. I'm going to take all my values to the other side. So I've got an x squared minus x minus mx, m squared x minus m squared. Okay, so if you were to put this, you could take out an x here. I'm going to just put it at the back though, and I'm going to be left with, I just want to double check, sorry, that should have been positive, so this is x, sorry, this is 1 minus m squared. Okay, so if you can see, this is now looking a little bit more like a quadratic. I've got an x squared, an x, and just a constant. Okay, so believe it or not, this can be factorized. Okay, I have not done this before, so this is something that I'm going to add to my long-term memory. Okay, if you've got an x, you can break down your x squared into x and x, and then what I'm going to do here is I'm going to break my m, instead of saying m and m, I'm going to say m squared and 1. Okay, but one of these has to be negative, so I want this to be positive and this to be negative. Okay, so it depends how you do your factorizing, but here you can see x minus m squared, x plus 1 is equal to 0. So let's just double check. I've got x squared plus x minus m squared x minus m squared. Okay, so that actually does work out. And here I can see x is equal to m squared, or x is equal to -1. Okay, so what did we just work out now? We worked out where does the curve and the normal meet. So we already know the curve and the normal meet at one of these points. We already know they meet at x minus 1. Okay, so the point that we don't know is the other one. So this over here, this x value must be m squared. Okay, let's just jump in here. So that x value is m squared, and then what did they say? They said find the coordinates. That means they want x and y. Q. Okay, so I know that that's my x. I'm going to plug this into the curve again because I don't like that c. I don't like needing to solve for c. But there's my curve. Now I can plug in y. Sorry, I'm not plugging my y. I need to plug in my x, which is m squared. And this is going to get me to minus 1 over m. So my coordinates for q are now m squared and minus 1 over m. Okay, I just want to make sure that I've got that. Okay, that is the correct answer. So I think the big tricky part is this part over here. Just working out how to factorize that is quite something. Okay, you could also use your quadratic formula, so maybe give it a go by taking your a is 1, this is your b value, and this is your c value, and plugging that into your quadratic formula. But just quickly, before ending this video, I want to just think a little bit more about this factorizing. So I'm going to go from this line, actually this line over here. Okay, so if I had x squared plus x minus m squared x minus m squared is equal to 0. Okay, if you remember your factorizing, there is a way that you can factorize if you have 4 factors. Okay, that's what I want to zoom into right now. So not 4 factors, 4 terms. So what I'm going to do is I'm going to group 2. I'm going to group this x, and I'm left with x plus 1. And now I'm going to take out an m squared, and I'm actually left with x plus 1 as well. Okay, and then this gets me, now I can take out the full bracket here and here. I can take that out, x plus 1, and I'm left with x minus m squared. And I think that's actually going to have been the easier way to solve this. So you can try it with a quadratic formula, which is quite complicated. I just do it a little bit later down here. Try it with a quadratic formula. Try it with your method that you know with factorizing. But then what I want you to do is also add to your list of how to factorize. You need to always have in your mind your list of factorizing. Okay, factorizing, my list is number 1, take out something common. Always look out. Sometimes that's the easiest way to factorize something, is take out something common. Number 2, difference of squares. Okay, go and look that up if you don't know what it means. So take out something common, difference of squares. Then you could have your typical trinomial. And the last one is grouping. And that's what I had here. When you've got 4 terms, if you ever have 4 terms, you need to go to grouping. Okay, so if there's any one of these that you're not 100% sure of, maybe just take some time to pause and study them and write somewhere for yourself, these are the steps to factorizing, so that you can always be able to do something like this. This one I do think was definitely tricky, but as soon as you spot that there's 4 terms, grouping should actually have come to mind. Okay, so I hope this helps. I think I'm going to also make another video on how to do this using the discriminant. But here is this question solved using differentiation.